of October. Chemistry without history of chemistry, without poetry of chemistry, without chemical folklore, without, I would even say, chemical gossips, is dry and boring. The second use of Second Life for chemistry-related people is a vehicle of humanitarianization. To show how it may look like, let us fly now from ACS Island to Ulrich Island. We are flying now over highway. Why no traffic? Extensive infrastructure, landscapes that Aldrich can afford, it's a rich company. To the Art of Science exhibit, with statue outside, inspiring to study science and chemistry at the Central Science. I think we should harness pseudochemistry, quasi-chemistry, parachemistry, even alchemy to stimulate student interest to chemistry. All vehicles are good. Oh, here we go. Chemistry Hall of Fame. Certainly the number of chemists is great, so we can make more statues or hand portraits. It's easier. We can click on any guy around here and learn what he is famous for. Who's that? On click, the statue gives us a note card to read. So it's Abu Musa ibn Hayyan, also known as Geber, inventor of over 20 types of basic chemical equipment. Why not building national chemical galleries? Polish chemists, Ukrainian chemists, French chemists. So this one is a German chemist, Erwin Schrödinger, author of an awesome equation. Some popular internet services like YouTube can be streamed into Second Life, like this chemical cinema where everyone can pick an element and watch a video about. This cinema functions as a social network. We can invite our kids to watch movies in world. We are community, we are united on a basis of chemistry. And it is also a vehicle of humanitarianization, because videos can feature people in association with chemistry. Let us now address Second Life as a learning environment. For chemists too, not only for students. These are poster presentations by professional researchers in Second Life. They are clickable, so we can instantly read about what our colleagues are doing. As you may have understood, we are back to the island of American Chemical Society. Let us check what they have inside. It's a decent building, modern, even modern. Freebies. It means we can grab this stuff for free. Molecule Razor. We can raise or retrieve, put a molecule in Second Life, and it is going to be 3D. T-shirts, lab coat and safety goggles, probably not so useful as in real life, but who knows. Periodic table is gorgeous. Assortment of molecules, always welcome. And let me buy this nice chemical carpet for $0 Linden. Greatest. Once we are in Second Life and concerned about chemical education, we should collect everything. Relevant, irrelevant, we can sort it later. Let us check out this interactive chemical museum. What we see entering and all around are molecular models. Rotating, seldom static, of simple compounds and complex ones, helping students to realize what it's like to be a molecule. A good visualization instrument to compensate lack of spatial imagination. And the learner is always in there, by the molecule, with the molecule. It's an absolute presence. Macro world and micro world merge in world. Chemistry is abundant in concepts that are tough to understand, not solely because they often involve a lot of mathematics, but because of incomparability of macro world and micro world in principle. We apply common sense to imagine micro-world, and at the same time we say that our imagination is limited and the macro experience is not applicable. An example is Heisenberg's principle of uncertainty, chemical bond theory, VSEPR and MO, and this set of atomic orbitals is to facilitate student understanding. One can take it to the inventory and then elsewhere res, compare, manipulate. The point is that we can make particles in Second Life behave according to our theories. Another issue is how consistent our theories are. Anyway, I believe that Second Life is a unique, immersive environment where people and molecules can live together, where people can better understand molecules through other people, and eventually better understand each other through molecules. Using this device in Second Life, one can manually run a chemical reaction. We see a big molecule, and to initiate a chemical change it is enough to type in a word, next, and this change occurs immediately. To run the reaction in the reverse direction, we type in back, and the products convert to the reactants. On this device, one can observe and run on molecular level the reaction of polycondensation, synthesis of nylon 6,6. Hexamethylene diamine molecules are coming from the left, hexane dioic acid is joining from the right, and the polymer chain is growing forever, producing molecules of water as byproduct. This 3D diagram is to teach the selection rules in atomic levels. Allowed transitions are green, forbidden are red, whereas yellow stands for the current state. As we click on a specific energy sublevel, we see the sublevels for which the transitions are allowed or forbidden. Let us try out the periodic table available greatest at ACS Island. Drag it from our inventory and res someplace. One more version of the periodic system. Let us click on element potassium column. We have all the basic information about some history of discovery, its appearance, behavior and uses, and it works for any element. Now I'm reporting to you from nearby a magnesium atom, risking to be hit by an aggressive electron. Actually, I'm kidding. In Second Life you can create things as phantom or physical, so these electrons are phantoms. I'm walking through the electron shell and manage to sit down on the nucleus. Amazing! Well, it's Bohr's obsolete model of atomic structure, yes, but it makes me feel involved, and I built this system in Second Life in 15 minutes. Here is what we can do with the assortment of molecules we saw at ACS Island. We can raise any of these molecules: ampicillin, benzene, caffeine, cholesterol, aspirin, sucrose, nicotine. And if we want them bigger, okay, we can magnify them. Now let us consider Second Life as a producing studio. For example, molecule we have just seen can be presented as an anaglyphic picture, and if you have special 3D glasses, one glass is red and another is green, you can enjoy this molecule with 3D. And it is Second Life that I took the two pictures of these molecules in with a shift that equals approximately the distance between human pupils. And it is Second Life that I can experiment with day, night, evening or morning, finding the best lighting to give a spatial taste of molecules. Another way to achieve the 3D effect is to produce stereo pictures of molecules. This way is technologically simpler and ensures natural colors, but has a limitation. Pictures cannot be big. Actually, distance between their centers should be about the distance between our pupils. Again, to produce stereo pictures I used Second Life. We can limit ourselves to chemical topics, or we can produce whatever of this kind, educational or just enriching. At some of my lectures I provide students with 3D glasses, turn off the light in the auditorium and project anaglyphic molecules and atomic orbitals. Students are happy. So to recapitalize, Second Life for the purposes of teaching chemistry can be considered as a social network, as a vehicle of humanitarian, as a learning environment, and as a producing studio. That is all I wanted to share with you about Second Life. Thanks, colleagues, for your attention. Thanks, Dr. Lomonauskas, for inviting me to be a keynote at your conference. From University of Oregon, with best wishes, Vladimir Slabin.